Hi, I'm Mr. B. During this lab activity, I will explain how to determine the percent of water and the number of moles of water in a hydrated compound.
So today we're going to do lab number 5. It's called percent composition of a hydrate. First, a little background information. Hydrates are ionic compounds or salts that have a definite amount of water bound to them as part of their molecular structure. The water is chemically combined with a salt in a definite ratio. Ratios vary in different hydrates but are specific for any given hydrate. An example of a hydrate is sodium carbonate decahydrate, Na2CO3.10H2O. This formula expresses how each molecule of Na2CO3, sodium carbonate, is surrounded by 10 molecules of water. The raised dot means that the molecules of water are loosely bound to the salt molecule. The coefficient, in this case 10, stands for the number of molecules of water bound to each molecule of salt. Though the coefficients differ for different hydrates, the coefficient for any specific hydrate will always be the same. This illustrates the law of definite composition. Moving on. When a hydrate is heated, the water of hydration is evaporated. The remaining solid is called an anhydrous salt. The general reaction for this is a hydrate gives an anhydrous salt plus water. The percent of water in a hydrate can be found experimentally by accurately determining the mass of the hydrate and the mass of the anhydrous salt after heating. The difference between these two masses is the mass of the water that was evaporated. The percentage of water can be calculated by using this formula. Percent of water is equal to the mass of the water divided by the mass of the hydrate times 100. In this experiment, a hydrate of copper sulfate will be studied. Note that the X indicates the unknown number of moles of water that you will have to determine in this lab. When a hydrate of copper sulfate is heated, the anhydrous form of copper sulfate is produced. This reaction involves a color change from blue to almost white, where copper 2 sulfate dot X hydrate will form copper sulfate plus X moles of water. The copper sulfate X hydrate is blue. The copper sulfate is white. This lab should help you understand hydrates and a law of definite composition. The materials used in this lab would be as follows: a balance, a hot plate, but we're going to use a Bunsen burner, an evaporating dish, hot hands, whatever that really means. I'm not sure what hot hands is. Safety goggles, a scoopula, a watch glass, copper 2 sulfate, hydrate, crucible tongs, and a weighing boat. Now for the procedure. Set up a hot plate to approximately 300 degrees Celsius. Well, since we're going to be using a Bunsen burner, I'm actually going to light my Bunsen burner that will burn at a temperature much higher than 300 degrees Celsius. Place a clean evaporating dish on the hot plate for 5 minutes and remove any water that may have been absorbed. So I'm going to place my evaporating dish on the hot plate to remove any water. Actually, the Bunsen burner to remove any water. Number 2, using crucible tongs or hot hands. Once again, I don't know what hot hands are. Pick up the evaporating dish, and place it on the balance. So, I think there was no water on this initially, so I'm just going to place that on the balance now. Okay. Then it says allow the dish to cool for 2 minutes, which we're not going to do. Find the mass of the evaporating dish after it is set on the balance for 2 minutes, which we're not going to do. Haha. This is mass A in your data. So in my data, A is the mass of the evaporating dish, and it is 84.04 grams. Number 3, using a weighing boat, measure out exactly 2 grams of copper sulfate hydrate. This is the weighing boat. I'm going to zero the balance, put a weighing boat on. I'm going to zero it again. I'm going to weigh out 2 grams of so that's 1.99 grams. So I have 1.99 grams of the hydrate. All right. Then it says record the mass of the hydrate and mass B. All right, so the mass is mass B, 1.99 grams. 4, carefully add the copper sulfate hydrate to the evaporating dish on the hot plate. Well, the evaporating dish was there. I'm just going to place that back up there and light the burner again. And cover with a watch glass to prevent spattering. All right, so I'm going to put there to prevent spattering. Okay, continue heating until the entire sample loses its color, becomes an off-white color. Then remove the watch glass with a pair of tongs. Record the color change in your observations. So, got a watch glass here. Just turn it around. Just like it. And you can see vapor on the watch glass. The vapor is actually coming from the copper sulfate hydrate. And I don't really think anything's going to splatter here, so I'm going to put the watch glass down actually. I'm going to take and the next part said, if there are any cake portions at this time, try to break them up with a scoopula, which is this, while simultaneously holding the evaporating dish stationary using crucible tongs. So I'm going to try to, okay, and you see the sample is actually turning an off-white color. You can see that clearly. Now what I definitely want to avoid doing here is heating it so long that it actually turns black. That would be a very bad thing. So I'm going to try to heat it uniformly without actually burning it. And I'm almost done. It's almost there. See, it's pretty much there. I just got, so We got that much. And I think that that's actually heated enough. Now also, it's a hydrate, right? And now it's the anhydrous salt. So when a hydrate becomes anhydrous, it will definitely want to take water back into its structure, its molecular structure. So I can't leave this exposed to the atmosphere too long because, you know, the atmosphere actually has water vapor in it. So I've got to, all right, so actually I'm good. Now I'm going to zero my balance again. And I'm going to add, so it says, continue heat for 5 minutes. Tongues or hot hands pick up the evaporating dish and place on the balance. I did that. After 2 minutes, which we're not going to do, record the mass. So the mass right now is 85.58. Okay, we're done. And now for the calculations. So first you have to find the mass of the anhydrous salt in grams. To find the mass of the anhydrous salt, we must subtract the mass of the empty evaporating dish from the mass of the anhydrous salt and the evaporating dish. So 85.58, that's the mass of the evaporating dish and the anhydrous salt, minus 84.04. And that's going to equal 1.54 grams of anhydrous salt. Now find the mass of the water lost. In order to find the mass of the water lost, I have to subtract from the mass of the hydrate, have to subtract from that the mass of the anhydrous salt, which is 1.54. You know, the hydrate was actually 1.99, so 1.99 minus 1.54 is equal to 0.45. So now I have to find the percent of water in the hydrate. To do that, I simply divide 0.45 by 1.99. That's the mass of the hydrate. And I get 22.6%. So it's 22.6% of water. Now it says calculate the moles of water produced in this experiment. To calculate the number of moles, I divide the mass of the water, which is 0.45, by the gram formula mass of water, which is 18. And that gives me 0.025 mole. And then it says calculate the moles of copper sulfate. So copper sulfate has a mass of 160 grams. So 1.99 divided by 160 is equal to 0.012 mole. So now, in order to find the mole ratio, I have to divide both these values by the smallest value. So if I divide 0.012 by 0.012, I get 1. If I divide 0.025 by 0.12, I get 2. So the X in the hydrate is I actually got 2. X is 2. but according to the data, the formula on the bottle, X should be 5. So I guess I'm off a little, I guess I rushed it a little bit. But anyway, so basically what I calculated was CuSO4.2H2O. It should be CuSO4.5H2O. So I kind of messed this up. At any rate, that's how it's done. And so just remember, just be careful. You know, we're very limited in time here, so I had to fudge the experiment a little bit, and I paid for it with these bad results. But anyway, that's exactly how you do it. So if you're doing this lab in class, just remember, try to follow the instructions, okay? All right.
So as you can see, the results from the experiment don't always go as planned, especially when you don't follow the protocol, as I didn't follow this time. But in general, the procedure that I just showed you is exactly how you find the percent of water and moles of water in a hydrated compound. Thanks for watching this video. Take care.